Hi everyone, welcome back to CHM421 Analytical Chemistry. We will continue our learning on the complexometric titration. In this video, we will discuss about water hardness. The determination of water hardness. Normally, the raw water or the tap water are hard water. So, hard water is due to metal ion, normally minerals that dissolve in the groundwater. This mineral can be include calcium ion, magnesium ion, iron positive, sulfate, and also carbonic ions. ADTA titration are routinely used to determine the water hardness in the laboratory, meaning that the ADTA determination of water hardness results from the reaction between the ADTA ligands and all the metal ion in the water. So the hardness problems in kettle, water heater tank arise result from boiling of water over a period of time, so that the water is evaporated. The calcium and magnesium salt become concentrated in precipitate in the wall of the container, so it can cause the water hardness. So the hard water can cause the soot scum, the clogged pipes, the clogged boiler. So here is a few example of the problems normally happen in the daily life due to water hardness. All right, the damage of the dishwasher interior, the lime scale in the water heating element. Lime scale also can block the piping system, shower, the block shower head, or the lime scale build up on the tap, the tap pipe or lime scale can be in the water heater cylinder. In many cases, the concentration of water normally the concentration of calcium ion is greater than the concentration of other metal ion in the groundwater. Therefore, we can measure the water hardness based on the concentration of calcium ion via EDTA titration. So this table is show the degree of water hardness. The water hardness can be rating, either it can be rated is a soft water hardness, medium, hard, or very hard. It very depending on the concentration of calcium carbonate. Okay. Determination of calcium using EBT is indicator. As I mentioned just now, the concentration of calcium is greater compared to other metal cation in the water. So we will determine the amount of calcium in order to know the water hardness. So determination of calcium using the EBT is indicator in chrome black T indicator. Is in principle the calcium ion will reacted with ABT to form calcium ABT, which is red complex in red color. So the problem with this calcium ABT complex, the end point reach before the equivalent point. This is the main problem. When we determine calcium using the ABT is the indicator. The endpoint appeared before the equivalent point. Remember, when we do the titration, the equivalent point will come first before reach the end point. But in this case, the end point comes first before the equivalent point. This is because the calcium ABT complex has a small value of formation constant, meaning that the complex is less stable and easily to dissociate. Calcium 2 plus ion are used in the titration with ADTA, and hence the end point appear before the equivalent point because of uncomplex indicator. So meaning that when we do the titration with ADTA, the complex between the calcium and ABT will be unstable, dissociate. So it's an uncomplex indicator. This is why the endpoint appeared before the equivalent point. So at pH 10, calcium ABT is red. So the ABT alone, the indicator in the pH 10 is blue. So formation constant, if you still remember your basic chemistry, calcium reacted with ABT produce a complex of calcium ABT. So the formation constant, this one is a concentration of product over concentration of reactant. The determination of calcium with ADTA using ABT is indicator will result lower than the phoric value because the endpoint reached before the equivalent point. Since the endpoint is reached before the equivalent point, the change of color from red to blue very slow. So calcium alone cannot be determined by using ABT as indicator. Okay, so by using calcium alone, we cannot use the ABT as the indicator because the Ca ABT complex unstable. Ca ABT complex is unstable. Okay, this is why it reached the endpoint before the equivalent point. So how to overcome this error? A small amount of magnesium ion will be added to the standard ADTA solution. So the magnesium ion we add on the ADTA before the titration begin. So the titrant in the biorate uh, will be Mg ADTA. All right. So the true concentration of EDTA can be determined by using standardization. So hopefully you still remember what is the standardization all about. If you forget about it, please refer to the previous video. So when the titrant is added to the calcium 2 plus ion in the conical flask, the following reaction takes place. Calcium reacted with ADTA. ADTA is the titrant in the biorate. So the calcium will replace the positions of magnesium. So it forms calcium ADTA complex. Uh, the calcium ABT is red color, and the magnesium ABT also red color because we use the indicator of ABT, internal indicator ABT. So ABT is red in color. Hence, the magnesium ABT will remain undissociated until the equivalent point is reached. So meaning that the magnesium ABT is a very stable until it is very stable. It won't dissociate until it reaches the equivalent point. As compared to the calcium ABT is a least stable, so it will be dissociated easily. That's why the endpoint reached earlier before reach the equivalent point. A small EDTA is added, the reaction between the calcium ion and the EDTA proceeds as long as the calcium ion still present in the solution. Okay, so if no more calcium ion present, the end point will be reached. The end point will be reached. So magnesium ABT plus EDTA. Magnesium ABT is a red complex. So the ABT after dissociated, EBT at the pH 10, it becomes blue. Problems with the EDTA titration can be solved by using chemical masking. Chemical masking. A complex is sometimes formed to trip metal. So the complex form will trip metals that interfere with a chemical reaction. For example, if we have calcium, magnesium, and EDTA, we will add the Cn is the masking agent. So the Cn will be masking, or it will mask the interference, okay, to make the result more accurate. So the Cn, which is a cyanide, will acting as the masking agent. It masks the interference of calcium 2 plus, for example, the zinc, cadmium, or mercury. So I hope you still remember on the previous video we have talking about chemical masking to eliminate the interference. Okay, another way to overcome the problem with the EDTA titration, we using the auxiliary complexing agent. We know in the basic solution, the metal will be react with EDTA. But many of them, the metal ion, normally will form hydroxide. For example, calcium hydroxide. This hydroxide react only slowly. This hydroxide react slowly with EDTA, making titration impossible. So the metal ion, calcium, magnesium is a very easy to react with the presence of hydroxide. So it can form the insoluble hydroxide. So the hydroxide compound reacts very slow with the EDTA. So meaning that the titration is impossible because the concept of titration, the chemical reaction happen between the titrant and analyte. It should be fast reaction. So in order to avoid this problem, auxiliary complexing agent, normally ammonia will be added to form temporary complex soluble with the metal. The temporary complex will then reacted with EDTA in the basic solution. So it forms a weak complex with the metal to keep it is a solution at higher pH value, right? Okay, so I think that's all for the water hardness. On the next video, we will cover several calculations related to complexometric calculation. Okay, thank you. See you again on the next video.